Hey listeners, we are excited to have you joining us for episode 766 of People Behind the Science. Today, we'll be resharing our interview with our guest, Dr. Joe Dunkley, originally broadcast on July 30th of 2018. Listeners, Joe is a cosmologist, and her job involves studying the universe. She conducts research to try to approximate how space behaves as a whole. This includes looking into space and taking measurements to determine how the universe began, what it's made of, how it's growing, and what is going to happen in the future. And in our interview, Joe talks more about her life, her career, and her research. So get ready to meet another great scientist in this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of the People Behind the Science podcast. Today, I am delighted to introduce you all to our guest scientist, Dr. Joe Dunkley. So, Joe, thank you so much for joining us on the show today. How are you?
I'm very well. Thanks for having me.
Well, I'm delighted to hear that you're enjoying your wonderful Friday today, and I'm excited to talk to you more about your work and your life. But first, I want to take a moment to introduce you to our listeners and give them some background on you and how you got to where you are today. So listeners, Joe is a professor of physics and astrophysical sciences at Princeton University. She received her master's degree with first-class honors in natural sciences from the University of Cambridge and her PhD in astrophysics from the University of Oxford. Afterwards, Joe conducted postdoctoral research, and she was subsequently a visiting research fellow at Princeton University. Now, before joining the faculty at Princeton University, Joe served on the faculty at the University of Oxford. And over the course of her career, Joe has received numerous awards and honors, including the Maxwell Medal from the Institute of Physics, the Royal Astronomical Society's Fowler Prize in Astronomy, the Royal Society Rosalind Franklin Award, the Royal Society Wolfson Merit Medal, and also the Philip Leverhulme Prize from the Leverhulme Trust. She also shared the Gruber Foundation Cosmology Prize, a NASA Group Achievement Award, and most recently, the Breakthrough Prize for Fundamental Physics with the Wilkinson Microwave Anisotropy Probe team. Now, in our interview, Joe is going to tell us more about her experiences in life and science. So, Joe, we're excited to hear more about your work, but also more about you. So can you start by telling us how you like to spend your time when you're not doing science?
So my life is pretty busy outside work these days because I have two young children. So I have two daughters who are almost 1 and 4. So most of my time outside work these days is spent hanging out with them. So I have a good balance between physics and family these days.
I like it. It's got a nice ring to it. So what are some of the kids' favorite activities these days?
Well, my older daughter loves running and drawing and singing. The fun thing is that she's studying space right now in her class. So she's having a good time asking me questions about space.
I love it. So in terms of people who are outside of science asking about space and some of the work that you do you have a favorite way that you describe this work to someone who's not in your field?
I'm a cosmologist, so my job is to study the universe as a whole thing, which might seem like a kind of overly grand aim, but it's actually possible. We try to approximate things in it and try and work how the whole of space behaves. So I try and understand how it began, what it's made of, how it's growing, what's going to happen to it in the future. And then I have various ways of doing that job by looking out into space and making measurements.
I like it. And I think you have the advantage in that a lot of people are just inherently curious about space. So they want to know more, right?
That's right. Yeah. I mean, I think these are fundamental questions. People have been asking the same questions for millennia. Why are we here on Earth? What's out there? What are we a part of? What's the bigger picture? That's what I tried to find out.
I love it. And you mentioned that it can be a difficult balance sometimes between physics and family and maybe some of the other things going on in your life. And I think as a scientist, it's helpful to have little motivation moments or inspirational things that you can carry in your mind as you go through your day. So do you have a favorite quote or a saying or something that keeps you going when things are a little bit crazy?
I do actually. So the quote is this, which is when things are maybe feeling a bit too difficult or too challenging. The quote is, just step up, you'll be fine. And this has come from a great woman, a friend of mine who actually died too young from cancer. She was this inspirational woman who just believed in seizing the opportunities and doing things. And to me, this says things can be difficult, but just seize the opportunity, do it, just step up, you'll be fine.
I like it. That's a good thing to keep in the back of your mind. When things get hectic and you're wondering if you're going to make it, it's just everything's going to be fine, right?
That's right.
And now you mentioned this woman as an inspirational figure for you. And I love hearing more about some of the people who've inspired the scientists of today. So are there others who maybe served as role models or mentors or people that you've just in general looked up to over the course of their career that you can tell us about?
Definitely. So 2 examples. One was actually my PhD advisor, Pedro Ferreira in Oxford, who was a real mentor to me as I was beginning to be a scientist. So when you do a PhD, it's the first real experience of research, and it kind of puts you into the field. It starts you out as a scientist. And he was someone who set a good example of, again, also having a strong life outside science while also being an excellent scientist. More recently, I had another role model back in Oxford who was Dame Carol Robinson, who's this amazing chemist and a fellow of the Royal Society. And she inspires me because she took a many-year career gap to have her kids, to have her family. And she did that, and she spent years at home raising her kids. And then she came back to chemistry and has become a world leader and is a dame and a fellow of the Royal Society and a professor in Oxford. And she's just fantastic. So I look up to her a great deal.
Certainly. And I really like that these people that you pointed out seem to be not only role models in science, but also in this idea of having a life outside of science and maintaining some semblance of balance as you go through your everyday life.
That's really important to me. I think there are many things that are important in life. And I think also I'm a better scientist for having time and interest outside science too.
Absolutely. Helps fight burnout, I think, if you have other things that you can devote your attention to.
That's right.
So now I'm curious to hear a little bit more next, Jo, about what first got you excited about science. So do you have some early memories of when this spark was first lit for you?
I do. I think my earliest memory really is of loving math. That was the thing I loved most at school. So it took a little while before I really realized what doing science was. And it definitely evolved from that initial love of mathematics. And then I gradually realized that you could use mathematics to describe the real world and to answer questions about why things behave they do. So as I became a teenager and learned more, I realized that it was using mathematics to describe and answer questions about the world around me that I really loved. And I went to university to study sciences. Again, I wasn't quite sure if I wanted to specialize in physics or chemistry. And in my first year at university, I had a class on special relativity. And it just completely captivated me. Mm-hmm. It was physics I'd never come across, and the idea of things behaving in a way that was completely unexpected. I found it just enthralling.
Absolutely. So then what took you from this university student just starting to get more interested in physics and this particular area of physics to where you are today? What are some of these key moments that really launched you into this career?
So I never knew I wanted to be a scientist, and I didn't even think that I wanted to be, even at the end of my university career. So many people could go straight from university to further studies, and I didn't do that because I left my degree having really enjoyed it, but thinking that I wanted to do something out in the real world. Mm-hmm. I spent actually my summers at university backpacking across South America and Southeast Asia and volunteering for environmental organizations. And I thought that's what I wanted to do, actually, was to work perhaps overseas and to work for an environmental organization.
Oh, cool.
So I kind of started out thinking about going down that path after my degree. But then, interestingly, I realized that my brain missed doing the mathematical, scientific thinking. And I was making some extra money by teaching maths to high school kids in the evenings. And I realized that was the piece of my day that I enjoyed the most. And I realized that my brain just really had to be thinking about scientific or mathematical things to enjoy itself. So I decided that I would go and do a PhD, and I would see if I liked doing research. And sure enough, I did. I discovered that I really liked doing it. And I loved doing it probably even more than I'd like studying it. Being a scientist is quite different from studying science. Figuring out how to learn something new and apply new tools to a completely unanswered question, I realized that this was a process I really enjoyed.
So what sealed the deal for astrophysics in particular?
So physics to me is so appealing because you get to ask questions about how things work and why things work the way they do. And we're defined as a scientist by the questions we ask, and we have to choose which questions we find the most fascinating. And I realized that answering questions about our origins and our place in the universe were the things that I found most fascinating. So I decided that that was the area of physics that was, to me, most exciting.
Certainly. And then after your PhD, you went on to do a postdoctoral fellowship at Princeton. Can you tell us about your experience there?
That's right. Well, that was particularly exciting because I was able to join this science team working on a NASA satellite. It was called the Wilkinson Microwave Anisotropy Probe. And it was a satellite measuring signals from the very early universe. And it had been running for a number of years, and it was an opportunity to join this amazing team of scientists. And it was a great honor as a young postdoc to get to do this. And it was so exciting because it put me at the thick of things. We were making the best estimates of the age of the universe and its contents and how fast it was growing. And as a team, we were getting to do that with the best data available. And that experience taught me that I also loved working in a team and working on a collaboration, trying to extract things as a group of people. So, for example, I realized that I wasn't the kind of person who just wanted to sit working on kind of theoretical ideas by myself. I wanted to be part of a team of people.
So then what brought you back to Oxford?
Well, a nice job offer. As scientists, we do these short-term, we do PhDs, we do a postdoc, and there are different goals, is to have a position where one can teach and do research in a kind of semi-permanent situation. So this opportunity arose in Oxford, and I loved being a PhD student there. And it was exciting to go back and to go back to the country where my family was. And it was also a very exciting job because the position was designed as initially a fellowship leading into a teaching position. So it actually gave me the space and time to do research and build up a research group before having to take on too many administrative responsibilities as a professor.
Sure. And then the group at Princeton, of course, was ultimately able to lure you back in. Can you tell us about your experiences there?
I've been back for a couple of years. My main motivation for coming back here is that I work on experiments that measure this particular signal. It's called the cosmic microwave background, and it's light that's coming from the very early universe. And this is what I've been doing for most of my career. But right now, one of the biggest exciting projects that's happening is a project called Simon's Observatory, happening in Chile. And this and related projects are being built in Princeton and other institutions. And this was a chance to come back and work very closely with colleagues who were building the experiments that I wanted to analyze the data from. So that chance of being in the same place as this group of people striving towards this new data, these new questions, that was really exciting.
Excellent. Well, you mentioned the Simon's Observatory as one of these exciting projects that you're working on. Would you like to tell us a little bit more detail about this project, or is there another one that you are also really excited about?
Well, the Simon's Observatory is going to start in a few years, and it's going to follow one that I'm working on right now, which is called the Atacama Cosmology Telescope, ACT for short. And this is also a telescope in Chile. It's high up in the Atacama Desert. And one of the things we're trying to do with it right now is measure how fast the universe is growing. There's this tantalizing discrepancy right now where we can use different astronomical measurements to work out or to kind of infer how fast space is growing. So, by the way, we think we live in a universe where space is growing, that it kind of began as a Big Bang and it's grown, and we're in an expanding space today. So one of our big questions is, well, how fast is it growing and when did it start growing? So you can take a lot of astronomical data, and right now there are these two slightly conflicting measurements. One where we look very far back in time and try and infer how fast the universe is growing, and one where we look at galaxies around us and try and do the same thing. And right now, there's a slight difference in what people are estimating.
It's never easy, right?
It's never easy, but they don't agree. So what we want to find out is this slight disagreement between these different measurements just because the measurements are really hard and maybe we have some uncertainties that we haven't really accounted for? Or is it telling us that our model for the universe is wrong and needs changing? And of course, that would be the more exciting outcome if we were to find that to be the case.
Certainly. So can you speak a little bit to how the Simon's Observatory is going to build on this AT project?
Sure. So what both of these experiments do is we're actually taking a picture of the universe as it was when it was only 400,000 years old.
Oh my, yeah.
A tiny baby. So the universe now is almost 14 billion years old. Mm-hmm. And the way we do astronomy is the further out we look in space, the further back in time we see, because light takes time to reach us. So the further it's traveled, the further back in time we get to look. So I measure this light that's been traveling the longest of all. It's been traveling since before stars and before galaxies formed. So it's been traveling since almost the birth of time. And we measure this, and it gives us a snapshot of the universe as it was when it was very young. So both the Atacama Cosmology Telescope and the Simon's Observatory measure this light. And our goal is to measure it in ever greater fidelity and ever greater sensitivity. So Imagine you taking a picture with a digital camera and you have not very many pixels, and then you would throw in many more and you could get much better resolution of an image. That's the process of stepping up to successively better telescopes. So we'll be basically trying to take an ever better picture of the baby universe.
Very cool. Well, Jo, thanks so much for sharing some of the details of these exciting projects that you're working on and working towards in the future. And I think despite some of the wonderful aspects of careers in science, there are down days and there are problems and challenges and failures. And you touched on a few of them in describing this project. But is there a favorite story of failure or challenge that you want to share with us today? And tell us a little bit about how you worked through a tough time.
So in my path through physics, the hardest time I had was actually when I went to university. And I found it incredibly difficult. So I'd always kind of done very well at school, in studies. And I went off to Cambridge University. And there you have to start by studying maybe 4 science topics. And then you decide which one you're maybe best at or like the best, and you specialize. And I had thought that I wanted to do physics, but I got there and I found it very hard. Mm-hmm. And I thought that I wasn't good enough at it. I thought it was too challenging for me. I thought, oh, everyone else is better at this than I am, and I'm the only person who's finding it just really difficult. And it took at least the whole of my first year at university to gradually work out that actually everyone was finding it difficult.
Right. You weren't alone.
I wasn't alone. Some people hide it better than others. And actually, this is a classic stereotype. And it's a measured stereotype, too, that on average, I think women students and male students who are as good as each other, the women tend to think they're not as good as they really are. I may have suffered from this stereotype. But I realized after about a year that actually I was just as good as other people were.
Right.
And that came about through, I guess, doing exams and gaining confidence. And then it all starting to make a bit more sense. But I certainly wasn't the person who always just flew through without effort. Physics is hard, but I realized that figuring out how to do something that was difficult was actually incredibly satisfying.
Absolutely. And I think these kind of early years of your career, when you're just diving into it, is sort of this critical point where, like you said, you either get these feelings of inadequacy or problems with self-confidence, and you kind of get turned off from a particular field in science or science as a whole, or you kind of stick it out and you make it happen. And it sounds like you did the latter, and it's worked out great for you, even though you kind of had those little road bumps in the beginning. And I think that's such an important message for our listeners to hear.
And I would hope to encourage other people that if they feel the same, that they should stick with it if they're enjoying it.
Definitely. So was there anything that really particularly helped you kind of stick with it and keep going despite some of these fears and feelings?
I was lucky because I had a strong group of fellow students, and in particular, I actually had a number of other women physics students, which is lucky in physics because there aren't enough of us. Mm-hmm. And I think we realized that we were not alone in these feelings, and other friends also convinced me that I could do it. And also teachers at the university as well gave me confidence.
Absolutely. I think kind of building this network of peers and making those connections with your teachers so that you can understand where you lie in the scheme of things and whether you're in a position where you can keep going, I think is really important. So thanks for talking about some of your strategies and how you work through this difficult time of transition early in your career. But we don't just want to focus on your difficult times. So Jo, can you tell us next about one of the exciting successes in your career?
Well, I mentioned this new telescope in Chile, the Simons Observatory. We've been trying to design exactly what it should do and what science it should do. And over the past year or so, I've been working with an amazing team of postdoc researchers and students to try and dig into each part of the scientific interesting things we could do with this telescope and understand what it can do. And we've got to the point now where we know what we want to do. We have these various science goals, things that we want to measure, things like measuring signals that can tell us about the birth of the universe and measuring signals that can tell us about the invisible universe, about things like dark energy and dark matter. And we've got to the point now where this amazing group of people have said, right, here it is. Here's what we can do. Here's what we're going to go and build. And here's the science that we can get out of it. And there have been many things that have been very exciting to me in my career, but just being able to do this recently and being able to pull this together has been a recent excitement.
Well, congratulations. I think it's a big step kind of having those plans or outlines finally in front of you so you can really see in front of you in person what's going to happen.
That's right. And now we're going to start observing the sky in 2021 for 5 years. And I just can't wait for the data. So we have this exciting path ahead of us looking to making these observations.
Yeah, 2021 sounds far away at first, but then I think the time's going to fly. So
yeah, we've got to get ready.
And now with the Simons Observatory, I understand that this is a massive collaboration. So can you speak a little bit about the collaborative aspects of these projects?
It is. So we're maybe a couple of hundred people, which for science is big but not huge. Mm-hmm. Things like the Large Hadron Collider is a larger collaboration, but it's quite sizable. And I love that because being part of a team, it's a thrill because you get to achieve so much more as that team than you could possibly do as an individual. And so everyone has their piece to play, be it from designing parts of the telescopes or the cameras through to designing how to build software pipelines to analyze the data or to extract the science. So we try and make sure that everyone does have their own unique piece and contribution to make. And everyone wants to know that they're contributing in an important way, but that they haven't got too much that's being expected of them.
Right. It's not daunting. Yeah.
Exactly. Yeah. So I think that working out where people's strengths lie and how we can all come together to achieve this is a really enjoyable part of doing science.
Very cool. Well, it sounds like you've got quite a bit to keep you busy, both in the world of science and outside of science. And one thing that I know I'm trying to sort of cram into every nook and cranny of my day is more time for reading. So that's something I love chatting with all of our guests about, our book recommendations. So Joe, I know there's a lot going on right now, but do you have a particular book that you're either reading at the moment or one that you've read in the past that you can recommend to me and our listeners?
I can. And I've actually just been finishing writing a book myself on astronomy and popular science. But in the context of doing that, I read this fantastic book called Chasing Venus by Andrea Wolf, who actually is someone I know. And it's a book about the history of these two incredible transit of Venus measurements that were made in the 1760s. And as an aside, I will say that most of my time I enjoy reading novels, but this was a book that I read for a reason and I just was entranced. There were these incredible expeditions made all over the world by astronomers to go and measure the transit of Venus. And the goal was to try and figure out how big the solar system is, how far away the sun is from us. And they were hugely challenging expeditions, people traveling for months in very hard conditions to go and try and do science and do it together. And this book is just telling the story of the people and the efforts involved. And I think it's fantastic.
I love it. And you hinted that you have a book coming out as well. It is both about and entitled Our Universe. So can you tell us a little bit about this experience of writing a book?
Yeah, so I wrote it mostly a couple of years ago and it's now in the final stages. And it's a book targeted at the public and with no expectation of any scientific background beyond perhaps a little bit of school background. So it has no equations, no mathematics in it at all. Mm-hmm. And I really wanted to be able to explain what we know about the universe in a way that was as easy to understand as possible. I think that often there's the perception that astrophysics or astronomy is difficult, and I decided that I thought that people shouldn't think that. Right. That actually there's so much stuff that we know and there's things that people can grasp without it being too difficult. So my goal was to try and write something that anyone could read and hopefully appreciate some of the exciting things that we've learned to know about space and tell some of the stories of how we know it as well.
Well, I look forward to this book. I will admit that I'm one of these people that has a little bit of difficulty wrapping my head around some of these sort of big concepts of space, the universe, and a lot of the astrophysical principles. So I think it's great that you have this layman's version where you don't have to have all of this inherent physics knowledge and background going into it. I think that's really important.
I think, yeah, there's an awful lot that one can know and understand without needing that background. Of course, to make progress in the research sphere, you need the tools. But most people, to learn a huge amount, you don't need all those tools.
Certainly. And in talking about some of the projects that you're working on these days, we sort of hinted at the fact that you're able to travel quite a bit for the work that you do, Joe. So is there a favorite place, if you look back on all the different places you've traveled to for science, whether it was for conferences or collaborations or to work on some of these telescope projects, is there a favorite place you've been to for science?
Definitely. So it's actually the site of our telescope in Chile. It's the Atacama Desert. So the northern Chile. It's this incredible place because it's a highland desert and our telescope is up at 5,000 meters in elevation. It's basically the highest telescope almost in the world. And it looks a bit like the moon up there or Mars. The landscape is very different to most other places than is seen. I first of all think it's beautiful and stunning up there, but also it was just so exciting to be up helping our telescope to work because actually I'm someone whose most of my work is theoretical and I analyze data and I compare data to theories, but I don't build experiments and I don't normally make telescopes work. So I had a chance to spend a couple of weeks helping the telescope to run and helping to just keep it going and keep it in check. And that was so exciting for me to see it in action and to help it be in action in this stunning place too.
Well, it sounds wonderful. Have you been able to go back and visit the telescope now that it's up and running?
Well, I've been 2 times. I went once when we were just installing it in 2007. And then this last time I went was 2010. But in the intervening years, I've had my 2 kids. So traveling to Chile is less high on my agenda right now, but I want to go back soon.
Certainly. So in terms of the other travel that you do you find it is difficult to kind of balance family life, the research life in the lab, your other responsibilities as a faculty member, and a lot of these great opportunities to travel that are maybe hard to turn down?
I could be traveling a lot more than I am at the moment. And I've chosen not to at the moment travel so much. But it's still possible. So, for example, next month, I'm going to give a talk at a conference in Spain, and I'm taking my daughter there, and my mother is going to come and meet us and look after my baby daughter. And we're going to combine work and a family visit too. So it's possible and also fun.
Absolutely. Well, wonderful to hear about some of the travel opportunities that you've had in this beautiful sounding place in the Atacama Desert where the telescope is located. And I think that throughout our conversation, we sort of hinted at the collaborative nature of the work and the wonderful people that you're able to work with as a scientist. And I think there are so many amazing, creative, fun, and funny people working in science, but that's not always the reputation that scientists get outside of science. So I love to try and break some of the stereotypes that people have out there by just kind of sharing the stories of the fun and funny things that scientists do when they're together, whether it's weird lab traditions or just fun memories that you've shared. So do you have a story, Joe, that really highlights this human side of science that you can share with our listeners today?
Sure. So when I was a graduate student back in Oxford, I was there at a lucky time because we formed an astrophysics band. We had a musician actually working as an artist in residence with us in the department.
Oh, cool.
And he encouraged a group of us, including himself, to form a band. So we get together and practice late at night in the lab, or in the department anyway. And our rule was that we had to play only space-related songs.
That's amazing.
I actually play the cello, and we tried that. But in the end, I moved to the theremin, which is an electronic instrument that you play just by waving your hands around. And that was really fun.
Absolutely. Well, the cello, you're right, doesn't necessarily work well with a lot of the normal band instruments. So,
Exactly.
So what was the name of the band?
We were the Big-Eyed Beans from Venus.
Ooh, very cool. So do you still play the cello or perhaps the theremin these days?
I do still play the cello, although right now my cello is in England and I'm in the States. I need to collect it and bring it over here.
Gotcha. Well, wonderful to hear about this band. And I think it's wonderful to be able to also experiment with your creative side, not just thinking analytically and critically about things in the lab. So it's a good outlet, I think.
No, it is. I think those things are really important. In fact, here in Princeton, we have the physics recital, which is all the amazing people who play instruments or will be playing tonight in our department.
Oh, that's awesome. You're going to have to get your cello so you can participate next year.
That's right. Maybe.
Well, wonderful to hear about the musical side of your graduate experience there. And we've talked about some of the big questions that you're tackling in your science today, Joe. But I know that there are barriers and every scientist faces them, whether it's funding or staff or technology or feasibility limitations that keep you from answering those questions that truly keep you up at night. So if I took away all of the barriers, what is the question that you are most curious about, Joe, that you would want to answer?
I want to find out what happened at the start of the universe, and I want to find out if it even had a beginning. And even though we have ways that I hope we'll be able to try and understand it, the feasibility here is a challenge because I just don't know if we'll ever be able to get back far enough to find out what was happening right at the beginning. I'm trying anyway, but that's the time at which I'd like to be able to figure out what was going on, because that was the beginning of it all. That's the thing I find most fascinating.
Certainly. So what is the biggest barrier that you're facing and the kinds of questions that you're asking in your research?
Well, there's 2 things. So in studying the universe, one of the barriers is simply feasibility of having access to being able to look at something. So, for example, I will never be able to see parts of space where light hasn't been able to reach me from. And I may never be able to access the part of space or the universe before the Big Bang because I will never be able to see it. So that's kind of a philosophical or intangible barrier, but it is one of the barriers in doing astronomy and cosmology, is just the limitations of what we're able to ever access out in space. In terms of more tangible things, if I had infinite funding and infinite people, then we could just have many, many telescopes with millions of detectors of incredible sensitivity to basically take pictures of the whole of the universe from its birth through to its age today. So we would be able to just almost make a movie of the whole universe. But that would require an awful lot of telescopes.
Right. And a lot of people to analyze and interpret the data. Yeah.
Yeah. So we just pick the key things that will help us put the picture together, and we try and put the story together from more limited resources.
Absolutely. Well, thanks for dreaming big with us today and sharing some of these big challenges and opportunities in your field. And I think over the course of your career, not only do you get to start to chip away at a lot of these exciting questions that you're working on, but you also get to work with some amazing people, as we mentioned, who are great sources of advice. So Joe, is there one piece of advice that you received that you think was just so helpful that you want to pass on to our listeners today?
I think the best advice that I was given actually was probably at high school, which was follow your talent for science. So I always loved other things too. I loved doing languages and studying literature at school. But a teacher said to me, and I think it was a wise thing to say, was that I could more easily pursue those things, other languages and reading books. I could more easily pursue them in my free time than I could pursue physics in my free time. And I think that's true. So the message was, if you can do science, study it as long as you can, because it'll be harder to do in your free time than other things.
Definitely. Do you find that you are able to, in your free time, explore some of these things that you still loved back then, like books and literature?
Yeah, I read novels. I love to travel to other countries and speak other languages. They're things that I have done. That doesn't work for everyone, but that's worked for me.
Certainly. Well, wonderful advice for our listeners. Joe, is there any other last piece of advice or a last note of inspiration that you would like to leave everyone out there with today?
I would like to say to people that they should do what they enjoy, and you've got to make it fun as well. So the process of doing what you do should be fun, not just the end result. And I guess my other thing is, again, don't panic if you find something difficult. Just keep working at it and it'll come.
Certainly. And know that you're not alone, that other people probably find it difficult too. Yeah. Well, great message to leave our listeners with today. Can you tell them if they want to learn more about you and the great work that you're doing, where should they go?
They should go to my Princeton University website, which they can find if they Google my name, it should pop up at the first place. And also I'm on Twitter. So if people have questions for me, I suggest ask them on Twitter or find me there.
Excellent. Well, listeners, definitely get connected with Joe on Twitter. Ask her any questions if there's any burning questions in your mind. And Joe, thank you so much for joining us today on our program and sharing a piece of your story.
Thank you.
Well, it's been a pleasure to chat with you and wonderful to have you here with us as well, listeners. We'll see you next time on another episode of People Behind the Science.